Hey there, physical science peeps. This is Miss Reork. This is Vodcast 6.1, and we're talking about chemical reactions. All right, chemical reactions, guess what? They happen every day, all the time. So what are some different chemical reactions that you could possibly come across every day? Well, one of them is breathing. Yeah, guess what? When you breathe, you take in oxygen and you breathe out carbon dioxide. Chemical reaction happens inside of you, right? Yeah. All right. What about photosynthesis? Okay, photosynthesis, the plant takes in carbon dioxide and changes it into oxygen. Ah, okay, let's see. What about when you eat something and you digest it? So digesting food is an example of a chemical reaction that happens all the time, every day. Let's see, what else? I know we can come up with at least one. Well, what if you were to make a fire because you were cold or you had to burn something? So burning fuel is an example of a chemical reaction. And not even making the fire, but when you drive your car, you burn fuel, and that's a chemical reaction as well. All right, so there are signs that a chemical reaction has taken place, and there are 5 of them. We're going to be concerned with the first 4, but there are 5. All right, so the first sign that a chemical reaction has taken place is formation of a gas. Now, typically what you're going to see here, if it's in a liquid, is bubbles, okay, or smoke. So formation of a gas. Okay, another one is formation of a solid. And we don't just call it a solid, we actually have a name for it. It's called a precipitate. A precipitate. I know most of you think precipitation, you think, oh, it's going to rain, because that's what the weatherman uses it for. Well, this is precipitation, means that you're forming a solid in chemistry. All right, another example would be a color change. Okay, if it changes in color, let's say you put red and yellow together, and you expect to get orange, but you get purple. Okay, that's what a color change would be. Okay, if you add red and something that's white and it becomes pink, we don't consider that a color change because that's something that's supposed to happen. But if it changes into something that it's not supposed to change into, that's a color change. All right, change in energy. Okay, so we've already talked about these before, but let's talk about them again. There's 2 ways it can change in energy. It can release energy, so exothermic, or it can gain in energy, endothermic. And then the last one would be if there's a change in pH. Okay, we need to make sure that we concern ourselves with the first 4. If you remember the 5th one, bonus. Ha! All right. A chemical equation is just a representation of a chemical reaction. So here's an example chemical equation where we have HCl plus NaOH gives us, or arrow, NaCl plus H2O. All right, so what are my reactants here? My reactants are everything that's on the left side of the arrow, or the arrow is pointing away from. So HCl and NaOH are my reactants. And my products, whatever the arrow is pointing to, NaCl and H2O. Well, what does that arrow mean? Well, that arrow means yields. And those of you who drive, it's not the same yield triangle arrow triangle that you see when you're driving that says you have to slow down and give the right of way to the oncoming traffic. It means to produce. So yields means produce, make. I spelled that completely wrong. That was funny. Produce, make, form, synthesize. Let's see what else. Produce, make, form, synthesize. Any synonyms that you can come up with this. Okay, now if it's a decomposition reaction, which we'll get into, then it's going to mean breaks down into, or decomposes. Okay, and if you can't remember, then, and when we get to that, I'll explain it a little bit better, but if it breaks down or decomposes, it's one thing going into many. Okay, word equations are just going to be names of elements or compounds that are used to indicate substances and the amounts used in the reaction. So an example of a word equation would be aluminum sulfate reacts with barium to produce barium sulfate and aluminum. Okay, now we would translate that into the chemical equation by taking, we say this is an ionic compound because it has a metal first, so we need ions or charges, and we would take those charges and swap them, and we would end up getting our formulas for our compounds. Reacts with, we put a plus, barium is Ba. Produce, arrow, barium sulfate, remember barium is a +2 and sulfate is a -2. Oops, here I am going crazy and just writing whatever I want to write. Let's fix that. Okay, so this would end up being BaSO4 plus Al. Okay, so this one here that I just wrote is the chemical equation. This one is going to be kind of a word equation. Okay, so we have FeO2 plus O2 gives Fe2O3. What are my products? What are my products? Remember, the products is what the arrow is pointing to. So our product is Fe2O3, which would be considered iron 3 oxide. Okay, what are my reactants? Well, my reactants are what make the product, so Fe and O2. Not too bad, right? Okay, some symbols you might want to know when you're doing these. Just in case you come in contact with a small s in parentheses, it means the substance is in the solid state. If it's an L in parentheses, typically it's going to be a cursive L in parentheses, but you can sometimes see it like this. It's not a 1, it's an L. It means that the substance is in the liquid state. If you see a Q, it means it's an aqueous solution, so the substance is dissolved in water. And if you see a G, it means that the substance is in the gaseous state or it's a gas. All right, a catalyst, even though this isn't on your paper, we needed to talk about it. So a catalyst is a substance that, what word do I want to put here? It helps a chemical reaction, but it's not used, or it speeds up a chemical reaction, but it's not actually used in the reaction. So an example here would be iron plus oxygen gives us iron 2 oxide, but guess what? This water right here is your catalyst, and it is actually what's going to speed up the reaction. So what is the catalyst? H2O. How is the catalyst shown? Well, it's usually written on top of the arrow that points to your products. Okay, so if you ever see that written like that, that's the catalyst. What does it do? It speeds up the reaction, but it's not used in the reaction. All right, so balancing equations. The law of conservation of mass, or law of conservation of matter, says that matter cannot be destroyed or created. It just changes forms. Okay, it can't be created, can't be destroyed in physical or chemical processes. It simply changes forms. Okay, a balanced equation, both sides of the equation must have the same number of atoms for each element. Okay, and when you're balancing equations, when we get to that, only the coefficients may be adjusted to balance an equation. Never change the subscripts. You can't change the subscripts. Okay, you can't change the elements, but you can change the coefficients. Okay, so it just gives you some examples here. So C plus O2 gives us CO2, Fe plus S8 gives us FeS, but guess what? You can't go in and change that 8 there. You can't do that. That's not allowed, and we'll see why when we get to that. What you can do is you can change your coefficients in front, right? So what goes in front here is what you can change to make sure it's all balanced. All right, when we're balancing equations, when we're writing equations, pay attention to the Brinkelhoff elements because they are diatomic, and I think that's it. All right, so that's the end of this one. We'll see you later.